All right, so today we're going to look at a sample problem that uses coefficient of kinetic friction. And here's the problem. So I have 3 people in a sled, and the combined mass of those 3 people plus the sled is 250 kilograms. They are on a hill that makes an 11-degree angle with the horizontal. And the coefficient of kinetic friction between the sled and the surface is pretty low. It's 0.08 newtons of friction per newtons of normal force. So it's slippery. There's not a lot of friction. The first thing we want to do is draw a force diagram for the sled and the sled's occupants. All right, so for our force diagram, there's going to be 3 forces acting on the sled. There's a weight vector pulling it down, and the size of that vector is going to be the mass of the sled and the occupants times 9.8 newtons per kilogram. The normal force is perpendicular to the surface of the incline. And this is going to equal the size of the weight force times the cosine of the angle. And then up the ramp, we've got some friction. And the size of this friction force is going to be mu times the normal force. All right. Now, just a reminder, we're calling the surface of the incline to be the x direction. Perpendicular to that is the y direction. So friction force is in the x direction. Normal force is in the y direction. The weight is in between. All right. Now, the component of weight that pulls this sled down the ramp is mg sine theta. All right, now, you don't have to put this in your force diagram, the green one that I just drew. The force diagram would consist of the 3 forces. I was getting ahead of myself a little bit. You need this for problem B. Now, problem B asks, determine the acceleration of the sled. So first, I've got to recognize that the sled's going to accelerate in the x direction, and that's going to equal the net force in the x direction divided by the mass. Now, I've got a force of mg sine theta down the ramp, and what that's called down the ramp, the positive direction. I've got a friction force up the ramp, let's call that the negative direction. Now, n is mg cosine theta, so the friction force is mu times mg cosine theta. All of that will be divided by the mass. All right, now, you might recognize that the masses cancel out. All right, so this simplifies to just g sine theta minus mu g cosine theta. Now, you might also recognize I can factor out the g's, so I'm going to do that. So I'm going to get 9.8 times the sine of 11 minus 0.08 times the cosine of 11. And when I plugged in all the numbers and did this out, I got 1.1 meters per second squared.